So whenever.
The green light's on, so we should be broadcasting. And we're going to start at the top of the hour. We have quite a bit of material to cover, and so we should be starting in about 30 seconds here, and I hope everybody is ready to go. All right, everybody. I'd like to welcome you all to the latest webinar introducing our Wrangler system here at TAC. I'm Niall Gaffney. I'm the Director for Data Intensive Computing. I'm joined here in the room at the lectern by Christopher Jordan, who's in charge of our Data Management Collections Group, and Weijia Zhu, who's in charge of our Data Mining and Statistics Group. And we're going to give a whirlwind tour, I think, of sort of the capabilities and how we expect people to interact with this new Wrangler system sort of intended for modern data-intensive computing. Start off, we do want to thank the National Science Foundation, who have funded through the ACI, the Advanced Cyber Infrastructure, the Wrangler program, and hence why we're all here. And also thanks to our partners, the University of Indiana and University of Chicago, as well as the vendors who helped us put this system together in Dell and DSSD, which is a subsidiary now of EMC. Thank them very much for their contributions. So today we're going to start off with sort of an introduction for those who haven't seen this to Wrangler's hardware and its capabilities. Continue on from there and talk about some of the usage modes, how we expect Wrangler to be used and the different ways that people can interact with it. Talk about allocations on Wrangler. Wrangler is a data-intensive computing system as opposed to a high-performance computing system, and there are slight differences in how we need to allocate Wrangler and have people request the services of Wrangler. We'll talk briefly then about our service management portal, or as we may call it many times in this, the data portal, which is the infrastructure through which people can make requests and stand up services on Wrangler. And then talk briefly about data management on Wrangler, how we anticipate people to both get data on and off as well as manage data within the system on Wrangler. We'll then take a break after about 50 minutes. There usually is a little bit of a lag. I will warn everybody out in YouTube land of about 45 seconds. So we'll take a break and sort of let that lag catch back up and make sure that we can cover any questions that we've had in the first 50 minutes, as well as give anybody a chance to take a break and need to stretch their legs. Then start back in the afternoon and talk more there about the different analysis modes that we anticipate people working on Wrangler, how people can work with different forms of databases in different ways, utilizing our Hadoop and Spark infrastructure on Wrangler, and then just sort of general analytic computations on Wrangler and how we see those going forward. Finally, we'd like to just sort of close and turn things back to questions. We'd like to, if they're just general questions, we'd love to answer those, but we also are looking to see if people want to discuss perhaps other use cases that we may not have covered in here or thought about. We may talk a bit to those things, as well as then talking about future detailed training opportunities for the specific infrastructures that are on Wrangler for programs to take advantage of. So the sort of, when Wrangler was sort of conceived, we sort of reviewed the way that things were going with our HPC infrastructure and how data compute was taking place there. And we saw some fundamental differences between sort of the data access patterns for what folks who do data analytics do versus what people who do high performance computing do. And the real big difference is just, you know, when you're doing HPC, you're running a large piece of code and then you're writing out very large sequential results. Whereas most people who are doing analytics are working in sort of a small read environment, sometimes of hundreds, if not thousands, to, you know, well, I won't put a cap on the number of how many files you may be working with. It's a very different I/O access pattern. And so we thought that that was something that really needed to be covered by whatever system we were coming up with. In addition to that, we know, working with data researchers, that most people who work with data are more interested in the science and the results and less in the technologies. And so they don't really see a problem with creating 4 million, 1K files on a disk and then working with them at random. Whereas people who have been in the HPC business and understand what happens to a file system and its metadata server would look at that and sort of be shocked. We don't anticipate data people to understand that. And so part of what we're really trying to do with Wrangler is to create a system where people don't need to really work in the same way that high performance computing people work. So the goals for Wrangler are to be able to address large and small data sets at all scales in a reliable and secure environment, to be able to handle different types of data, structured data or unstructured data. So if you have a bunch of files that are unstructured that you analyze, it's a different access pattern than putting everything in a database, but we want to be able to support both of those. And then make it fast. The limitations these days on most data compute problems are caused by I/O, and so we wanted to make this as fast as we could for both large file access, but also small sequential accesses, or people needing high transaction rates using databases. Wanted to support a wide range of applications and interfaces, ranging from, everybody thinks in the current sort of data space where everybody is hot on Hadoop and Spark, and we want to definitely support those, but make sure we support a lot of the other languages and data systems that people are still working with and are getting good results with. And we really also wanted to move beyond this idea of a scratch file system where files can be purged. We want to have a file system and infrastructure behind that file system to allow us to keep that the data and the results of the research, make them shareable and usable by people, as well as collect the metadata and keep a good structure on those data, so that they will be useful in the future once the researchers themselves may no longer be working with it, but for people who are trying to reproduce or use other data. So for that, we designed a system that has 3 primary subsystems. At the top here, you see sort of a 10 petabyte replicated file system. I'll get to the replication in a second, but it's sort of your classic, file system where you can keep lots of files. We anticipate that being an area where people bring data in, export data out of, and work with people on data sort of in between computing runs and work in that environment. There's the second environment in there, which is the analytics cluster. This is a modest sort of cluster by the scale of something like our Stampede system, but it's a cluster of compute nodes that people will be able to run things like Hadoop, R, databases, and other forms of data compute workflows in, and take advantage of the last subsystem. The last subsystem is this high-speed storage system, which is sort of the flagship of what Wrangler is wrapped around. This is a 0.5 petabyte of NAND flash storage that is directly attached to those analytic nodes. And the anticipated throughput on that file system is the ability to sort of read at about a terabyte per second rate across the entire cluster. Or in terms of what people who do high transaction rate databases are interested in, that equates to about 250 million I/O operations per second. And we are in the process right now of commissioning this system and bringing it up, and we are, we expect to hit those numbers soon. At large, Wrangler is a distributed system. We have a sister system over in the University of Indiana, which is where we are replicating that 10 petabyte file system. So we have a second copy of everything that's stored in Wrangler there, along with some more analysis and access nodes so that people will be able to get to that file system in the event that the file system here at TAC is not available, or also being able to take advantage of that as more compute engine. All of this is then connected by way of 40 gigabit per second Ethernet infrastructure, multiple lanes linking into the 100 gigabit per second public network that TAC and the University of Indiana are part of, which gives us a very high throughput between the two different sites to keep everything in sync and to be able to work at both places. The storage systems, there's sort of an image of the storage system on the floor right now. It's both of them put together come to 20 petabytes of raw disk for this project term storage, the ability to store data on the system for longer than just the time that you're working with it. The performance on the read writes on that system should be about 75 gigabytes per second once everything is going. And for those who are interested in sort of the details, there are 34 storage server nodes and 272 different storage targets within the system, which allow you to handle in parallel multiple IOs across the entire system. And this system will be exposed to the users as sort of a traditional file system. It is mounted on the current system in /data, but also by way of an IRODS-based interface, which will allow people to take advantage of this more managed storage system, where people can put data in and also metadata associated with that information and keep better track of files than simply putting files in directories and trying to remember how big it was and when you wrote it and all those sort of things for you. Analysis hardware is very sort of commodity hardware. Other systems like Comet, very much, it's pretty much the same sort of server. We have these 96 nodes and 24 nodes over at Indiana of Haswell servers, each with 128 gigabytes of RAM, connected by way of the 40 gigabit Ethernet connection and a 54 gigabit per second Mellanox FDR network. But then the centerpiece of this is the DSSD storage, which is the innovative component. And I just want to note that DSSD is not SSD storage. It actually is directly attached NAND flash, which is the high-speed storage you can get a hold of directly attached to the bus that the CPUs in all of these different systems are communicating over. So it has the fastest communication that you can get to the NAND flash memory available. It's not limited by any other infrastructure out there besides the internals of how fast you can talk to and from the CPU. So it's not limited by the 40 gigabit per second or 56 gigabit per second IB networking. It's not tied to an individual node, so this isn't as though you have taken some flash storage and put it inside of a node. It is connected across a fabric so that all nodes can get to that storage. And this means that, it has the potential of being exposed as a half a petabyte of storage that could be used by one or multiple nodes. Makes it a very flexible and scalable system. There's, as I say, more than half a petabyte of usable storage once the flash system is rated within those servers that you see over there to the left. And it's also very versatile and reliable in that the flash itself is capable of handling continuous writes to the storage units for 5+ years without loss due to the memory wear that you may hear about other flash systems. So it is a very robust system as well. So why would you want to use Wrangler? Well, you want to use Wrangler for a multitude of reasons. If you have problems where you are limited by the current storage systems, either on your lab computers or your desktops, all the way up to something like Stampede, where you have lots of small files to process or lots of random I/O to do, sort of in that mode that really isn't well suited to an HPC system. Another use for Wrangler that will probably come to pass fairly soon, is the need to analyze some of these large data sets that are produced by these HPC systems. So you may be running large models on something like Stampede or Comet and have the need to go through and then sift through the results from your analysis to find those areas of interest, and or to do statistical analyses on the features within your model's outputs. And so this is a system where you could easily bring in large outputs from other systems and do fast non-sequential analysis of those models to come up with better results. In addition, we want to support more of a style of computing that most data people enjoy, which is sort of on demand. So allowing people to actually get clusters or subclusters inside of the system for longer periods of time than the typical 48 hours that you're limited to in runtimes on environments like Stampede, where you can get on and work either in a batch mode or in a collaborative mode within a lab. So you could have multiple people coming and working on data sets for a period of weeks to months. If you have the need for databases, Wrangler is a fantastic place for you to come. It's one of the few places, I believe, in the Exceed environment where you can run both persistent and what we're calling transient or interim databases. But it's also, if you have the need for databases with high transaction rates, where what you're analyzing or doing needs many reads and writes per second, this is a great environment for that. We already have some successful use cases in that area. If you need use for Hadoop or Spark workflows that need a high performance backing HDFS file system, this is the place to come. We have that capability in production now and hope to improve on it this summer. If you have the need to have a data set that many users will want to work with. This is a sort of another unique area that Wrangler can come to play. If you have a public data set, which say many labs or many different researchers would want to work on, we're very interested in the ability to host large public data sets that will be useful to a research community within Wrangler that multiple people will then be able to use. And so rather than trying to distribute that data around on multiple systems, give people a place to come to and work on that data together. And if you have any sort of job that is currently I/O bound, Wrangler is really a good place for it. An example of that is sort of shown here, and I'm not going to talk to all of the plots there, but this is a quantum chemistry code that was actually running on Stampede, and the bottom plot down there shows that at no point during the run there did that code ever reach beyond sort of a 40 to 45% usage of the CPUs within the cluster that was running this computation. And upon further analysis, this is because it was bound by the metadata servers of the I/O system on Stampede. A code like this would be able to run on Wrangler without these limitations, and would see well over a factor of 2 performance improvement simply by taking advantage of the high I/O throughput here. So while we talk a lot about what we can do with data on Stampede on Wrangler, there are uses for it in sort of modeling and simulation environments as well. There are things that Wrangler is not really intended for, but there are other systems out in the infrastructure in the Exceed ecosystem that I wanted to point out. So if you're in need of a very specific compute environment, very tightly constrained, cloud-like, Wrangler's not a cloud system. It has some cloud provisioning capabilities, but it's not something that you can configure and make work exactly the way that you want to. But if you need something like that, the upcoming Jetstream project is something that will be able to handle that and give you that cloud capability that many people need for their work. If you need more than 2,000 cores to do your computing, there just aren't that many cores on the system. And so the HPC systems like Stampede and Comet are still going to be essential for jobs that are working that way. And if you have need for large shared memory environments, we only have 128 gigs. It seems strange to say only on that these days, but if you need a terabyte or larger sort of shared memory environment, Stampede has that, and the Bridges system is up and coming and will feature even larger shared memory nodes. Talk a little bit here about the allocation model. As I said, the needs of data people are a little different, but also the structure of Wrangler is a little different in that there is, as part of this computational infrastructure, this flash memory system, which is essential to many of the problems that we run. Rather than try and carve things up into smaller units, we decided that we were going to rethink how Exceed could allocate a system like this. And we got away from this notion of a service unit, where a service unit was tied to a particular number of cores. In fact, one core is a service unit. Well, we wanted to really pull that flash memory in as part of the compute. And so in order to do that, we're starting to talk about Wrangler in the concept of a node hour. As opposed to an SU on Stampede, where you might get 16 SUs, which gives you a node for an hour, we want to just say 1 node hour equals 1 node. And with that node, you get the 24 cores, the 128 gigabytes of memory, but then an allocation or the ability to use 4 terabytes of the flash storage system that's attached to Wrangler. So when you're figuring out how you want to use the system, you need to sort of consider all of those factors in your calculation of how many node hours you need, how much capacity you need of compute on the system. In addition, because shared resources like databases that are running on one server are shared amongst folks, but are still something that we're having to support, we're going to also have a chargeback on that as far as node hours is concerned, and we will charge the rate of 1 node hour per day. Essentially, that goes to one of the cores on the shared resources, basically dedicated to your database. So we will also have that as some factor that you may need to figure out when you're determining how many hours you need to get on the system. A lot of words on this slide, and so I won't necessarily talk to all of them. I think I've spoken to some of them, but there is this notion of the compute allocation that I've been discussing here, and there are sort of the ideas of what you need to consider that I was just talking about, to what you need to figure out as to how much of the system you need to get your job done. And that ranges from the physical, what you need in a system from the compute point of view, but also if you're doing interactive jobs or working in an environment where you're going to have a whole lab working for a week or two on a data set, you need to think about how long that period of time would be. For each quarter, we're roughly putting up almost 200,000 node hours into the system, so you can sort of get a concept of how many node hours are available. And in addition to asking for this computational capability, most people will want to also ask for a storage allocation, which will give you a large quota on our persistent file system. Where you can have sort of a standard Lustre file system or IRODS managed data system or persistent databases that are taking advantage of the spinning disk storage system. Storage allocation, you sort of need to consider several different aspects of what's going on. It's not just about what you need to preserve, but you need to figure out how much data are you going to be pulling in and storing there before you get your analysis running. Any sort of information that needs to be preserved between campaigns or runs or analytics would have to go on there. And you have to also consider sort of any sort of collaborative data exploration that people may be working with other people on as you're driving towards publication. And then how much you're going to need to finally preserve the data beyond the scope of the computations that you're doing on Wrangler. Some sort of exemplary work or processes that people might be doing with 1,000 node hours, and I threw that out just sort of as a, it's a nice chunk of time. In classical sense, this would be, 24,000 SUs for those people who are used to thinking in SUs. But in 1,000 node hours, you could work to process, a 40 terabytes worth of data on the NAND flash in sort of a simple workflow over the course of 4 days, where you have 4 or 5 people all working together on it. Or if you're wanting to run a job through a Hadoop or an HDFS file system where there's replication of the data through the file system, so I think we're working at a replication factor of 2, that would give you enough capacity to sort of work on 10 terabytes of data for a week. And then if you're doing sort of more computational work, more modeling and simulation, this would give you the ability to work on, 60 to 80 terabytes of flash storage on a run across, 480 cores for 2 days. And so these are the sort of things that you could do with this nominal 1,000 hours, just as an example of what the capacity of the system can host. And of course, we have roughly, well, I was given the numbers earlier on how many per quarter of these 1,000-hour chunks there are. In addition, at that nominal rate of 1 node hour per day, you could host a total of 3 persistent databases for a year on the system. So working with Wrangler, you can work with Wrangler in several different modes. We support what we call normal jobs, which I think HPC people are used to working with. This is the idea of coming in and submitting large batch jobs that will then go and process data. If you have a fully self-contained job that is autonomous and goes and does its own thing and doesn't require any other human interaction, this may be the environment that you want to work in, such that you would stand up the job, it would then populate the flash memory, do the computation, extract results, save those results away, and then get torn down at the very end. Users can also request interactive jobs in sort of a normal job queue. In fact, we have a nice command I'll show in a bit called IDEV, which will allow you to get nodes on demand for doing debugging and development work. Additionally, for these normal jobs, we are working to get Wrangler integrated into TAC's Viz portal for the people who've used that in the past. This is a nice graphical interface which will allow you to go and sort of point and click, get things like desktop environments or RStudio or Python notebook environments running, taking advantage of the full Wrangler system. So just to sort of show what one of these batch type jobs would look like. Here I've logged into Wrangler. You can see that on the first line. Logs me in from the SSH session. I can use the SQ command to see what's going on the system, and this shows me that there are a few things that are waiting for the dev partition to be brought back up, and then it looks like Weijia been working really hard with some bash and a VNC session and an RStudio session, and he has those nodes that he's working with. I then go and I have this little test set job that I wanted to look at. It's a very, very simple job. The top of one of these jobs, you have to describe, what the name of the job is, and how long you expect it to take, and how many nodes it needs. And so there are these hashtag sbatch commands, which allow you to say these things so that the Slurm job scheduler knows what you want to do, as well as what account you're charging this against. And then below there, where it says you shouldn't need to edit anything, that's where the job itself is going to go. And you can put in there the actual sequence of events that need to go forth to do your computing. You submit that with the sbatch command. Sbatch will then go off and will then queue this up. It'll check and make sure that you've got all the resources that you need and that you'll actually be able to get that job running on the nodes that you're asking for. Apparently at that point there was we had something disabled. There's a little error message in there, but it tells you not to worry about it. Please get in touch with us. And so that's exactly what you could do. But indeed, at the very end, it says it submitted the batch job. And in fact, if I go back and look at that SQ again, you'll see that I've got my test job running in there, and it's been going for 55 seconds on that particular node. So that's how sort of batch jobs work on Wrangler. Reservations is a mode, though, that we're really trying to promote so that people can use multiple nodes and many parts of the system all at once. Data motion is the most expensive thing. It takes a lot of time to copy data around, even on a system like Wrangler. And so we sort of encourage people to try and have things that last for a longer period of time to take advantage of the data being in the flash memory for a longer period of time. We sort of anticipate these to be sort of data campaigns as we've talked about them, but there may be other reasons that people may do this. So for this, we like to be able to allocate Wrangler in like a cloud-like way where you can say, I need so much of Wrangler to do my work for the next, say, week and a half. The way that reservations will work is your allocation will be charged for the reservation from the start of the reservation until it stops. Any jobs that are run against the reservation are not charged to you. So the reservation itself is what costs. If you run a job outside of a reservation, you do get charged for that time. So you have to be sure to run any jobs that you have against that reservation. And many of the systems that we have in place will automatically do that for you. So here's that Wrangler data portal I was talking about. And so this is where you would make your reservations. So you can come into the Wrangler data portal, which is, if you can read that up top, it'll be linked off of the TAC portal so that you can find it. But you come in here and you click on login and do your standard login dance here where you give your username and password, and we will accept either your Exceed username or password or your TAC account. And I'm assuming once the Indiana portion is up, there may be options to take advantage of that as well. That will then take you to what we call the dashboard. And if you have multiple allocations on Wrangler, it will allow you to choose which allocation you want to work with. Once you choose that, you're led onto a screen where you can see what reservations are in place. You'll be able to see what reservations have gone past. As well as click on buttons to add new either Hadoop-based reservations or regular file system-based reservations. You can also request a database, and we'll have an example of that coming up later, as well as requesting allocations within the IRODS curated storage system. Up in the right-hand corner is sort of an interesting little pull down. You can get back to the dashboard. You can do things like that. But the other thing that it allows you to do is go to the user profile. While we're working on this screen right now, we hope to have information in here to help better introduce and expose people to where and what things are on the Wrangler system. And I don't want to go into the full details of why there are multiple accounts, but because we are hosted at many sites, there may be a need for different usernames for individuals at different sites. And so we'll keep track of all of that for you so that you can understand which account name you can use at the different sites. We'll also have in here names of your home directories, data directories, and other paths that will be important for you when you are working with the system in a more graphical environment and not so much a command line environment. So I said you can run interactive jobs, and here's just a little dump. You can come back and review this, but this idev command is a very handy command for being able to go and get a node and be able to work on that node for a period of time. The default time is 30 minutes. You can change that, but it allows you to get on the system. And here's an example of me running the idev command and going through and asking I want to be on this particular part, the D5_01 area of Wrangler. And it'll go through, it'll write the job that you need to submit to get that for you, submit the job for you, wait until it's ready, and once the system is ready for you to log in, it will log you on to that particular node. So it's sort of like using an SSH or some other command line client to get a session somewhere, only it takes care of all the back-end stuff for you that we need here to get your jobs running. And then once you're on that node, it is just like a regular node. You can see the various file systems and other things that we'll briefly talk about here, but are all covered in the user manuals for the system. We have this long-term file storage, which is mounted on several places. In that last slide, you may have seen a home directory. This is where people's configuration files can be stored. Not a very large allocation that you can have there, so it's not for you to put data there, but maybe source code and programs. Each user at TAC will have mounted from our global work file space an area where they have a 1 terabyte allocation and be able to use that as storage for not just Wrangler, but for all the systems here. It's shared amongst every system there. It's also saved in a environment variable called stockyard. If people are using this on multiple systems, I think we can give you some highlights as to how to use this to get information between the different systems. It's very useful once you understand it, but requires a minimal amount of explanation that I don't want to go into here. In addition, we have this /data file system, which is that 10 petabyte at each site file system, which is where you'll be storing interim results, data coming in, as well as preserving results from your computations. I'll skip over that slide that shows the different paths I was just talking about. and then go into the fact that we have these managed storage systems, the IRODS curated data system, which allows you to put files into it and get files. It works much more like a library. It's not a file system. You can't read the files until you get them out of it. But it keeps track of everything for you and manages that much like a good library would. In addition, we'll talk about these coming up, I think, in about a half an hour. Talk about the different databases that we have for storing data in structured and semi-structured form. So classical SQL style databases for folks who know and love those, as well as some of the NoSQL databases we hope to have given the demand from people who will be working on the system. The flash storage system is still evolving. We will have a final version of it where all nodes will be able to see all the flash storage soon, but at this point, due to some limitations in the software, we have 43 nodes able to access 200 terabytes in 2 different clusters. One of those has a GPFS file system, which is a standard file system that people know and love. You can use your fopens and file writers in Java and those sort of things to access data. And then we have an HDFS file system for people who like things like Spark and MapReduce, where they can work in that environment. In addition, our databases are connected currently to a 50 terabyte flash storage system, and that's the area that many of those persistent databases that need high throughput can put information. And as I said, in the final configuration, we will have all 500 plus terabytes of data available across nodes. And so the complexities that you see here will be going away, something we did in order to be able to roll the system out now, given the current software environment that we have. So with that, that's sort of a brief overview of the system, and we're going to move on to talk a little here about data management on Wrangler, and then hopefully answer any questions or discussions from the first half of the talk. So let me turn it over to Chris Jordan here, who's going to talk about this point.
Good afternoon. So yeah, I'm going to try and get through some quick details on data management on Wrangler in the course of the next 10 minutes, and I'll address kind of briefly general data management, but really what I'm going to focus on mostly in this section is the specifics of Wrangler and the kinds of details that you might want to take into account when trying to develop a data management plan for computation on Wrangler. So kind of general notes, the NSF and NIH now have requirements around data management. The point I really want to make here is that this is really doing you a favor. This is the kind of thing that you really ought to do if you're doing a lot of work with digital data as a matter of course, and the act of writing it down and submitting it shouldn't be that difficult because you should have the plan kind of already in your head. By analogy, if you were going to drive across country, you wouldn't just like get on the road and say, well, this looks like the direction east that I want to go. You'd look at a map and you'd see what are the roads that are available to me, what are the routes that I might want to choose. You might make decisions about which route you want to go down based on things like speed or the characteristics of the road. And a data management plan is exactly the same kind of thing. It doesn't have to be an elaborate, time-consuming kind of thing. It doesn't have to take you weeks or months to write it. It just involves thinking about what are the resources that are going to be available to me, what are the data elements I'm going to be creating and working with, and how do those interact to best accomplish the task that I want to accomplish. And this is kind of particularly important when we're talking about Wrangler, because Wrangler does have a lot of options. There's both local and non-local file systems. There's flash and disk-based file systems. And of course, it exists in the Exceed context where there's lots of other storage options out there as well. So kind of a brief guide to what's out there on Wrangler. So there's this /GPFS/flash file system that is obviously the flash storage that sits on all of the nodes. This is on all of the compute nodes. It's also available on the login node purely for data migration purposes. You won't get the same performance on the login node that you would on a compute node, but you should certainly get enough performance to move your data into that file system and have it prepared for when you do your computation. You want to treat this as a scratch file system, right? It's temporary storage. The amount of storage you have is going to be associated with how many nodes you have on the system. And it could go away because it's on the flash, which is not entirely volatile, but isn't as persistent as the disk. The /data file system is the Wrangler Luster disk-based file system. This is the 10 petabyte file system that Niall just mentioned. That's long-term, that's allocated. If you ask for a storage allocation on Wrangler, this is what you get. You get a certain amount of storage on the /data file system. The /work file system is our TAC global Luster file system. That's a 20 petabyte file system. That's not an allocated file system. You just get a terabyte of storage on there with a TAC account. You can ask for a larger one if you want. So this is kind of longer term storage, but it's not directly attached to Wrangler, so it may not have the same performance. But if you want to move data back and forth between Stampede and Wrangler, for example, this is a really good option to use. And then we have IRODS. What IRODS does is it's not associated with any specific resource. It kind of sits on top of all of the resources. You can put a file into IRODS and then essentially copy it onto other resources if you want. You can copy it between IU and TAC, Indiana and TAC, and you can do all of these other things around data sharing, publication, curation. If you want audit controls, checksumming, IRODS is the option to choose for that. We won't talk a lot about IRODS in this section, but I'll say a little bit more about it when we talk about transfers. So kind of key things to think about. I mean, really what this is thinking about all of the stages that you may go through in the course of doing analysis work on Wrangler. Right? You may have data, you may have some pre-processing that you need to do with the data that you bring in. It needs to be reduced or transformed before you can actually get it into your analysis framework and maybe prepared for moving into a database, for example. And that may result in input data that goes into an analysis system. You may then take that as input for more post-processing that may happen on another system. Visualization might be considered here. You may want to do archival over several years over the course of a project so that you can go back and validate your results later, or say, oh, I want to rerun that analysis, but with slightly different parameters. So I kind of call that project term archival. You might also have long-term archival. That's not necessarily something you would do on Wrangler. And then, of course, there's publication of the data itself, either sharing with your collaborators or just sharing it openly on the web. And for each of these, you may want to choose a different system. That you may not necessarily, you may leave it in one place for the whole course of your computation, but likely that's going to be a pretty simple workflow if it's really best to just have it on one resource for the entire time. So ways to get data into Wrangler, Grid FTP and Globus Transfer. Globus Transfer is just an interface to Grid FTP. Grid FTP is kind of the highest performance file transfer mechanism that we support and exceed. It supports parallel file transfer. You can do multiple nodes. It's the best way if you want to actually try and take advantage of the full bandwidth that we have coming into the system. Grid FTP is going to be your best choice to do that. And Globus Transfer basically provides you some simple interfaces to control Grid FTP transfers. IRODS also does some similar high performance parallel transfer technology, but it doesn't do multi-node transfer. And of course, because IRODS is a slightly separate system, you only want to use IRODS as a way to ingest data into Wrangler if you actually intend to be using the features of IRODS and having your data in IRODS. We don't generally recommend it as just a mechanism to transfer data. And of course, SSH and SCP is very widely supported. It's very reliable, pretty robust, been around forever, and it's very simple to use. So I generally tell people, you know, unless you're already comfortable with something like Globus Transfer or Grid FTP, try an SSH SCP transfer first. And if that looks like it's going to be sufficient in terms of performance for your needs, you don't need to learn any other tools. That's going to be enough for you. And then finally, we have this thing we call the data dock. Basically, that's the old station wagon full of disk drives. You can, in special circumstances, physically mail us or ship us drives, and we can load them for you from hardware here at TAC. Typically, you know, the network connection that we have coming into the building is much faster than the performance of any given disk drive. So unless you have some pretty specific limitations, this is not really going to be the most efficient way to get your data to us. But there are circumstances in which it makes sense. And we just encourage you to talk to us about that. Just a picture of the Globus Transfer interface. You can see it's a pretty web interface. You've got one system on one side and another system on the other side, and you've got little arrows. You pick a file and click an arrow, and it moves a file from one place to another. It's pretty intuitive, and all of the Exceed systems are already in this system, so you can just kind of type out Stampede in the dialog box, and it will find it for you, and you can pick it from the list, and it'll log you into Stampede. It's pretty easy to use. Little more on IRODS capabilities. I mentioned it has this virtual namespace. It has much more explicit control of things like replication and resource data movement, if that's something that you want. It has support for extended metadata associated with files, and it has these fixity capabilities. So data going into IRODS will be checksummed. You can periodically verify integrity. If you put your data into IRODS on Wrangler, we will periodically check the integrity of the data for you, and you'll be able to get reports on that kind of thing through that Wrangler portal. So that's kind of nice. There's also web-based access mechanisms for IRODS. So you can do both public and private data sharing over the web using IRODS. So this is a good mechanism to use for limited data publication, for example. And we have mechanisms for more open web-based data sharing from IRODS as well. And again, a picture of the IRODS Web Interface. You can see on the left-hand side there's a list of directories. The right-hand side shows you files. You can click on files and get information about their properties. That's kind of the main thing that's different from this and a regular web browser, is rather than just immediately trying to open or download a file, clicking on one is likely to give you a list of properties or things that you can change about the metadata, access controls, those kinds of things. Databases, the point I just want to make here is databases can have a lot of different roles in the course of your application, and I'll talk a lot more about that in the next segment. But it's kind of important to think about what is it that I'm using a database for. The flash storage can really accelerate a database, but it may not be that you need that, or it may be if your database is really small, it's going to fit in memory. You don't need to worry a lot about where your database is stored. So it's kind of important to understand what is it that I need out of this database? What's the nature of my data, and what kind of performance do I need out of it? If you have any questions about that kind of thing, then we do encourage you to submit a ticket. But that's kind of important. If your database is small, it may not really matter that much where you put it, but certainly if you want it to be persistent, you want it to be on disk, and if you don't need it to be to take advantage of the performance of the flash, then you can maybe save yourself some trouble by not trying to put databases on the flash. And with that, we're at 45 minutes. So we have a few minutes here where we can take a break. Folks can stretch their legs if they want, and we will answer any questions that you may have from the first couple of sessions. So we'll say just 5 minutes, and we'll start formally again at 1:50. Okay.
So the question is there any connection with Branch and Wrangler?
Only insofar as they're both Exceed resources. So they both support the same Exceed transfer mechanisms like grid FTP. We won't have, for example, Ranch mounted on Wrangler or Wrangler file systems mounted on Ranch directly, but you can transfer files to and from it the same as for Stampede. We might see some from Corral, which is our disk-based system, into Wrangler, just because Corral is not available to Exceed users at the moment.
So we'll still be breaking for a few more minutes here, but I just wanted to remind anybody who is out there who has questions, you can always pop onto, we have a chat room going right now at https://tac.etherpad.mozilla.org/21. There are many of us in there sort of answering questions. So if you have questions in real time as well, please feel free to ask them there, and we will get to them as soon as we can.
Okay, we'll go ahead and get started again here. All right, so I have about 20 minutes here to talk about using databases on Wrangler. This will be a pretty general presentation. There's a lot of ground here, and I'm not going to try and cover it all exhaustively. I'll try and give you enough information that you know how you would do this if you wanted to do it, and to give you a little bit of a roadmap to finding more information. So kind of the primary mechanism that we're supporting as far as databases on Wrangler are SQL databases, relational database management systems. The SQL language standard is very robust, powerful, mature. It's been around for decades at this point, and is very widely used in both industrial and research kinds of contexts. There are some very, very big, very important systems that are based off of SQL. And we support a couple of different ways of using SQL that I'll talk about in a minute. Kind of generally, SQL is a good mechanism to use for working with data when your data is highly structured. The kind of classical examples here are things like address books or music catalogs, anything where you've got really consistent data of a similar type across common fields. I'll talk here just kind of to give you an example of what relational data models look like. So you've got kind of 3 different tables here. The tables are related to each other by common values. Those are referred to as keys in the relational database parlance. And basically the keys relate data in the different tables to each other. And you can define lots of restrictions on what kind of data can go into the fields, on how the fields relate to each other. You can say, in an example like this, you can't put an author into this table unless they have an author ID that matches an existing author ID in another table. I don't really think that somebody named Haile Selassie wrote a book called Cold Fusion for Dummies, but it's interesting to think about. So SQL and NoSQL, I'll talk a little bit more about NoSQL examples in a few minutes here, but just to kind of give you a basic idea, the way that these systems work almost universally is as client-server systems. So it's not just an application that you're running. You have to start up a server process somewhere. The server process is what stores and interacts with the data directly on disk, or in this case, flash. So it's the server process that in a Wrangler example, you would want to be associated with the flash file system. And then you have clients, and it can be one client or it can be literally millions of clients all interacting with that same server and collectively utilizing that same body of data or managing that same body of data. And in many of these SQL contexts, there is a lot of importance placed on transactions and the ability of transactions to be kind of bundled together and to all happen all at once. So the example here is if you have a ledger application, you have to move money from one place to another, you're going to decrement one field and you're going to increment another. And it's very, very important to the bank that those two things happen at the same time, right? That you don't increase the balance in one area and then forget to decrease the balance in the other area, because you'd be making money out of nothing in that case. So that's the kind of thing that an SQL server system is going to do, is to try and impose that consistency across the data. And it's kind of important to think about this. If you're running a database server on Wrangler, the client to that database can actually be running anywhere. It doesn't have to be running on Wrangler. It really just depends on what kind of the balance of the computation and the data movement is in your application. If all of the work is being done in the database, and like an example I'll give in a minute, then you can run the client literally on your desktop, and all of the work will be done on Wrangler in the database server. So just kind of some examples of places where you might use an SQL engine, particularly on Wrangler. Web backends. This, for something like MySQL, I would guess that probably 95% or more of all of the MySQL installations in the world are doing this, web backend kind of activity. And basically that just means storing usernames, storing passwords, storing all of the account information, storing wiki information. So most wikis are using an SQL engine on the back end to actually store the wiki content. This is an application that we'll support on Wrangler through persistent databases. And you can mix, depending on the design, you can mix both kind of application level data like usernames and passwords and domain specific data, something that's, something like genome sequence data in the same database or in separate databases. But it's, again, thinking about data management, that's the kind of thing you would want to think about. Large tabular data sets, I've seen this a few times now in fields like social sciences, economics. You can get these big tabular data sets like, say, survey results. You can store all of those in an SQL engine and then essentially use that as a storage location from which you extract subsets that are used for further analysis. So you might say, give me all of the people who responded to this survey who are women, for example. That's the kind of thing. It's very easy to do in an SQL context. And then that gives you a subset from which you can do further statistical analysis. You want to explore the answers of all of the people who are women versus all of the people who are men. And you can also use the database as an application engine in itself, where really almost all of the significant analysis or comparison kind of work is being done by the database. I have an example of that here. This is the OrthoMCL example that I think Niall mentioned earlier. This does grouping of orthologous protein sequences, and don't ask me what that means. And basically what you're doing in an OrthoMCL application run is you're loading the output of BLAST, which is a very widely used genome sequence recognition tool. You take the output of that and load it into MySQL. Essentially, BLAST is going to give you a whole bunch of genome sequences that represent proteins, and you can pull those into MySQL. And then essentially what you want to do is a global comparison. You want to say, I want to look at all of these sequences versus all of these sequences and see and find sequences that are similar to a certain degree. And those are the kinds of things that SQL does very well. They can be computationally IO intensive because it's a global match kind of operation, but it's really easy to code it in SQL and really pretty quick to execute it, especially on a system like Wrangler that can read the whole database very quickly. And so OrthoMCL is an example of something where you can, and we have had people running the clients essentially on their desktop or their laptop. It's just running a Perl script that issues SQL commands to the backend server. The server is running on Wrangler. The storage is on the flash. And of course, they get Wrangler kind of performance out of it, not laptop kind of performance out of it, because all of the work is done on Wrangler. So NoSQL is kind of a term that's used generally to refer to a wide variety of software tools that essentially don't use SQL but do database-like things. And essentially, a really simple way of thinking about these NoSQL engines is that they're kind of trading off one or more of the characteristics of relational SQL-based databases for other characteristics like reliability, performance, scalability. That are some of the examples that I've given here. So if you want to do, so an example is most relational database systems, because they put so much emphasis on consistency in transactions, it's very, very difficult to make those node parallel and distribute them across a whole bunch of nodes and then still get performance, because you have to do all of these constant kind of global checks. Has this data element on the other side of the cluster been modified, or is it in the process of being modified? So if you don't care about that, you can throw that out and you can get an improvement in performance, because then there's a bunch of checks in the code that you don't have to do. Now, this isn't always necessarily the case, and there's a lot of work now, I think, particularly to try and get some of these NoSQL engines to have more of the desirable characteristics of relational databases because there are some big applications that utilize these in various ways. But as a kind of first approximation, that's a good way to think about it. The other kind of aspect about these is that they tend to be more specialized in terms of the kind of data structures that they support, or they're very, very general. So something like MongoDB takes JSON or XML data as its input, and it stores it as JSON and XML. So it can be aware of structure, but there's a lot of kind of optimizations that you might get out of more structured kind of storage that you won't be able to do with Mongo, because Mongo will let you put 5 different JSON documents with 5 completely different structures all in the same data store. So a little bit more about the usage modes that we support on Wrangler. This is kind of important because it's a little bit different than what you might see typically if you're thinking about database hosting. Specifically, we have both persistent and transient models for running databases. The persistent database is kind of your standard hosted database. It's always going to be there. You'll use your credentials for TAC to access them. They're plugged into the TAC authentication system. They're operated by us for you. A transient database essentially is just a database that you set up and run yourself on a compute node as part of a reservation and a compute task. And there's a lot more flexibility, obviously, in the transient model, but you are going to be responsible for setting it up and running it. And basically the idea here is you can use the database as a temporary engine for processing as part of an individual job or a campaign of jobs, rather than needing to have it there all the time necessarily. There are very lightweight options here. SQLite is one that really just uses a local file and is accessible via a library for most common scripting languages. And that SQLite is kind of the only thing I'll talk about here that doesn't have an explicit client-server model. So you don't have to be running a separate server. It's just treating a file as if it were the server, essentially. So a note about performance expectations, kind of the good news here, particularly for things like transient databases, because it's on a dedicated node, it's going to be associated with the flash, and you're going to be the only one using it. You can expect at least kind of 2 to 3 times faster performance versus a disk-based system. This is not directly equivalent to the speed advantage of the flash over disk, because there are a lot of other factors here, and this is going to vary a lot depending on what you're doing. If you have a really small data set and it fits in memory, then you're not going to see any difference between running a database application on the flash versus running it on the disk, because you're not actually touching the disk or the flash in either case. You're using memory for the whole thing. So there's a lot of those kinds of things that will affect performance, but in general, it is fair to expect if you're really doing something serious that is dependent on the storage subsystem with a database, you will get at least this kind of 2 to 3 times factor of improvement in performance, and you could get significantly more than that. Again, depending on the workload. So kind of what's the workflow for running a transient database? It's pretty straightforward. In general, we want people to have reservations and to use reservations. This makes particular sense in the context of running a transient database like this, because you are going to want to use it as much as you can over a long period of time. Another thing to kind of think about in relation to these is you can, as long as the data files that are associated with the database are still there, you can start up and shut down the database as many times as you need to. You can even move it from node to node typically without having any problems. As long as the data files are still there, that's not going to be a problem. So you could have, as part of your job script, something that just started up a database process on the flash, and as long as you still had your reservation, you still had your flash directory there, that would work fine. Or you could have a job that just starts up and runs a database continuously, and then other jobs are acting as clients to it. So there are a couple of different ways to do that. But basically what you're doing is you're getting a job on a node and you're going through whatever the software setup process is for that database. Now, MySQL and Postgres are kind of the things that we're starting by supporting. So these are already installed on all of the nodes. The server processes are. So it could be as simple as setting the Postgres environment variable, saying where the data directory is, and running the Postgres server process. Almost all of these, in fact, I can't think of any offhand that can't run in user space as a normal user. You can really do just about anything you need to from a database perspective, just within a job. I'll talk a lot about kind of the ones that we support here, but I want to emphasize again, there's no limitation on that. Because this is something you're doing yourself in the context of a job, any database technology that's out there that you're interested in, if you can get your hands on it, it's open source or it's freely available, you can pull it down to Wrangler and try running it and see how it performs. And there are a lot of them out there. And we'll try and provide some scripts for most of the most common options. So things like MySQL and Postgres, we'll provide simple scripts so you can plug that into your job script and just say, this is where my directory is, and start me up a Postgres server. So again, this is really flexible since it's really just like any other application. And I think I've already emphasized the point. You don't have to run the clients to the database alongside the database server. Now, if you have significant work that's being done, if you're doing something like the statistical analysis example I gave, where you're pulling a subset of data out of the database and then you want to do some analysis on that data, then you probably do want to run the computation on Wrangler, but you don't have to. You could run it on Stampede. If you have a job that is best suited for Stampede, but that's pulling data out of a database, you could run the database on Wrangler and have a job that actually spanned the two systems. There's nothing preventing you to do that. But this, this thing about the details of the connection and how you actually use it are going to be application specific. There's some commonalities that I'll talk about in a minute between the relational database systems, but once you get into the NoSQL world, it really is the wild, wild west. It's lots of different ways that you can access and use these, lots of different API models, all those kinds of things. So just a note here, of course, GIS, geographical, geospatial information is kind of increasingly important in a lot of different fields. I've given some examples here. We're formally supporting this through the PostGIS extension, but there are similar extensions for MySQL. And there are even database technologies out there that are really oriented towards GIS. And you don't necessarily have to have something that's really tuned for GIS processing at a fundamental level. GIS data is really just kind of collections of coordinates, so you don't necessarily have to have a GIS specific extension, but it can be helpful if you want to do things like do spatial searches where you're saying, is this point inside this shape? Those kinds of things are greatly aided by having GIS extensions. Okay, and another note here, I talked about this already, but the database in many cases may be part of some more significant, larger networked data service. Web pages are the common example. GIS layers are another example that I've given here. So you can run these things called map servers that will basically take GIS data and turn it into map images on demand as part of another larger application. So that's the kind of thing that I'm thinking about when I'm talking about these persistent services that are utilizing databases. And we will support these, but if you want an allocation on Wrangler for this kind of purpose, then the database piece of it, the piece that you want to run on Wrangler, has to be a really significant portion of what it is that you're doing, and it has to take advantage of Wrangler. So if you're running a wiki site and you want to put your user accounts and your content on Wrangler, that's probably not a good application for an allocation on Wrangler, because really any hosting provider could do that. Amazon could do that perfectly well. Yeah, so we are not going to try and support in detail all of the NoSQL options. There are probably at least 5 to 10 that are in pretty wide common use, and I'm sure there are dozens that have some size community. And if you count just tech startups that are using one of these, there's probably close to 100. In all. There's lots of different models, lots of different technologies. It's not at all clear which are going to kind of become the most popular or dominant, which are going to get the most adoption and support. So we're really kind of basing this on demand and on the user feedback. So we do encourage you, if you have a technology that you're interested in, that you need to use, and I don't mention it in this talk, then get a hold of us and let us know that you're interested in it. Ask us about it. We're always happy to hear what people need on a system like this, because it is novel. And I think I've pretty much covered this. I guess kind of the main point I would make here is, don't go to a NoSQL kind of option just because it sounds cool or because it's what Yahoo is doing. In most cases, the relational database stuff has been around for a really, really long time, and there's a reason for that, like C or Fortran. These are very mature technologies, and for most things, they're going to do the job pretty well. I generally tell people, go to a NoSQL option if you know that your data doesn't fit the relational model well, or if there happens to be a NoSQL option that exactly fits your model. So if your data is graph network data, there are graph databases out there that are exactly tuned towards working with that kind of data and the kinds of queries you would want to do on that data. So that's an example of a place where it really does make sense to look at graph databases rather than a relational model. But other than that, generally, I don't think there's a good reason to start with a NoSQL. The other kind of caveat here is if your data size or your problem size is such that that one node is not going to do it, that you're going to have multiple nodes working on a problem simultaneously, then the NoSQL options might be kind of good. And that's, to a certain extent, that's kind of like the MapReduce kind of model, is let's use lots of nodes to process this data simultaneously because we know one node's not going to do it. So just a quick screenshot of the Wrangler portal that Niall talked about, and specifically how you create a database. So when you go to the main portal page, the main project page, you'll see a Create Database button very soon, and that will take you to this page. And basically, this is just a form that you fill out that has fields for things like what's the name of the database you want, and what kind of database do you want. And like I said, the options right now are going to be MySQL and Postgres. This is specifically for persistent databases. The only thing that's kind of special here that I would highlight is the DBA user. The DBA user is the user that will have administrative access to, for example, define and change the schema. So it should be the person that's kind of responsible for controlling or managing the data within your research project. Should be the one that you designate as the DBA user. And just a couple of notes here, database clients, there's a lot of different ways of interacting with databases. All of the kind of common ones are going to have a command line client, where you're basically just interacting directly with the database, kind of a question and answer command line format. There are APIs certainly for MySQL and Postgres, almost any imaginable programming language, scripting language, there's going to be an API that will allow you to interact with it directly. And there's also support, particularly for Postgres and MySQL, from things like R, SAS, Stata, MATLAB, all of those kinds of statistical analysis or math packages will support the databases as a data source. So you can do that kind of subsetting thing that I was talking about directly from within SAS, for example. And a lot of those tools particularly are going through these JDBC or ODBC clients. And what this is just a standard for application interaction with a remote database. JDBC is just the Java version of ODBC. And for pretty much, for all of the major platforms, there are going to be ODBC connectors. The thing that's important there is just to know you might need to download and install these. If you want to connect SAS on your Windows box to a MySQL instance on Wrangler, you're probably going to need to download one of these ODBC connectors for MySQL. It's basically the client tool, but it's free. It's pretty easy to configure. And the way that you connect to these things, really this is kind of just like doing an SSH connection, right? So you've got a client package. You want to connect to a remote system, you need to know what's the host name. In some cases, you might need to know what the port you're connecting to is, what's the name of your database. And in something like a SAS or ODBC connector, you're just going to fill out those fields in the form and say connect, and it'll test it. The one thing to highlight here, well, I guess a couple of things. First of all, if it's a persistent database, it's going to be your TAC or your Indiana username and password that you use to connect to the database. And because it's your TAC username or password that you're using to connect to the database, you have to use SSL encryption so that not anybody can capture your traffic and steal your TAC password. And just another note, thinking about storage, we can do databases that are on disk in addition to databases that are flash. By default, it's always going to be on the flash. But if you have a particularly large database that doesn't have to be on the flash, if it is the back end to a web application where performance isn't going to be key, for example, you can do it on the disk. And of course, the advantage of that is it's going to be persistent. You can have the same data there for years. And if you need stuff like this, or if you need anything special, talk to us about it. And finally, just again to emphasize, this is an enormous area. There's a huge amount of both historical and active computer science work on data models, relational data structures, all that kind of thing. This is a huge area for industry. I mentioned Yahoo, pretty much, Yahoo, Google, Facebook. All of these big web companies are highly dependent on these big distributed databases. A lot of what they're doing, you could characterize, what Facebook does essentially is database management. They have a really big database and an application that sits in front of it. And so it's all about the database, the performance, the reliability of the database. So there's a lot of work out there going on right now and a lot of historical material. So the advantage of that is there's tons of good documentation online, both on things like relational databases, SQL, and the newer NoSQL stuff. If you want to, if you want to see people arguing over whether NoSQL is superior to SQL or debate the fine points of various models, you are in luck. Just go online. But I do want to encourage you to go out and look at that information, because there's a lot of information, particularly on things like tuning and optimization. How are you structuring your data, and how are you storing it? And how can you do so most effectively to accomplish a specific task? And in many cases, just doing your data structures right within a database can produce at least as much of a performance improvement as moving to Wrangler in the first place can. So with that, I will pass it off to Weijia, who will talk about data analysis support.
Hello, I'm Weijia Xu, and I will talk about the data analysis support we have on Wrangler. So since we have a lot of resources at TAG and more on the XC that can supporting people running computations, so the analysis is kind of the everywhere. And let me start with the goals we had with Wrangler and how the analysis is supported differently on the Wrangler than the other resources. So first, my first bullet point is we want to support both small and big data analysis tasks. So the small data analysis has one of the very common use cases we see is nowadays people do a lot of like streaming data processing where they want a single small process that constantly capturing the incoming data stream. So for this kind of job, you need a place to run them, but Stampede certainly not going to be a best place for you to run them. You're going to just waste all other resources on that node if you just only use one node for such small task. So the big data analysis task is on the other end of the spectrum where you have terabytes or multiple terabytes of the data. Your algorithm or your analysis need to repeat access to them and do analysis iteratively. And that put a lot of strains with pressures to the storage subsystems. That may not be suitable with a lot of current HPC model where they have one global shared storage system theirs. So with that, it's basically, especially if you had in the past, you had the experience where your job running on Stampede has been killed by our admins for certain reasons, then that's definitely a cue for you to think about or consider Wrangler as your better choice for running those type of analysis tasks. So the bullet point is we want to support in both interactive and batch processing analysis models. So in the typical HPC clusters, and we strictly supporting the batch processing, where you're wrapping your analysis into a job submission scripts and you submit to the back-end cluster and running them. But increasingly, we see more and more requirements and needs, and people want to do analysis interactively, that especially with the big data, because you want to see your analysis result and be able to make decision on what you are going to do next and what kind of analysis you want to run next. So we want to supporting that part very well with the Wranglers. If your workflows require a lot of those kind of interactivities between you and your data and your data analysis process, then the Wrangler may be a better choice for that as well. On Wrangler, we are also going to put more emphasis on supporting people doing a specific research on certain domains, and there are a lot of domain-specific tools out there that that may not be currently installed on things like Stampede or other resources, but we can find a way to accommodate people on those type of the application and make them make the analysis viable on Wranglers. And then lastly is there's a new trend on especially with the open source scientific analysis environment, is they begin to be more into a heterogeneous programming environment where you may have a code that written in Python, but that the Python code may call another C libraries or Java code or in between to form a complete end-to-end workflow for the analysis. So that type of the heterogeneous programming and the application case is going to be more and harder to support on other resources, but might be a good place. But Wrangler might be a good place for those kind of workflow as well. So with that side, the analysis support on Wrangler is basically we put them onto three big aspects. One is for the big data analysis task, we're going to support in things like Hadoop and Spark. Those are two things that now is kind of the standard for big data analysis. And also we are going to supporting a lot of general purpose data analysis. Those things are, most of them are already available on other resources as well, like Stampede. So we have R and Python, all of those are also installed in Stampede. But on Wrangler, we have more memories per node than Stampede's node has. So if you had a problem where you need more memories for your R script or for your R processings, then you may want to move to Wrangler and to do the processing here. Lastly, is we're going to getting more feedback from users on what kind of the domain-specific projects they need, and we are going to trying to find a way to supporting those projects as well. So with that, let me start talk about more details on how we are going to supporting the Hadoop cluster and Spark analysis on Wranglers. Now the big data is really a common popular word, and big data analysis is something you see all the times. From very beginnings, and then there's many options you may have in terms of what analysis or tools you can use for big data analysis, but most of them pretty much I can say all of them are originating or still based on this idea called MapReduce programming models. Some of them is changing or evolve depending on applications, but two of the key ideas the MapReduce programming model has is one is moving the computations to the data, so it has this type of the data localities and to reduce the data movements. And the secondly is it's trying to give a simplified programming interface, whereby define a simple programming interface. It has implementation details on how the parallelism should be implemented. So the end users can developing the application more easily and make the computation more easy to be scaled out. So the Hadoop is one of the first implementation of the MapReduce programming models in the open source fields. It started with just a simple Hadoop libraries. When I first used them, it's just one jar file. All you need is in that jar file. But over the years, there's more company and more bigger companies and actually use them in their backend processing. So for them, the Facebook, Twitter, they're all using Hadoops for their backend processings. And more people do the development into there. So nowadays, the Hadoop has been evolved into a sort of full-fledged application, and in some sense, it's more like a platform for big data analysis. There's a lot of application built on the Hadoop's distributed file system called HDFS, and more application that has been built around the Hadoop clusters. So the Hadoop cluster is getting more and more complicated. So how we can get started with Hadoop on Wranglers is actually quite simple. So we put them, you just need a two-step to access and start to using Hadoop on Wranglers. So first you need to create a Hadoop reservation through the Wrangler data portals. That's what you have now has been showing the screenshot of the data portals. Then once you have that reservations, you can submitting a Slurm job and to requesting one of the node from Hadoop cluster and to start to use them. So you have seen several screenshots on the data portals, and this is what you will see once you click that blue button on create Hadoop reservations. The Hadoop, whether you're using before or it's the first time you heard about it, it's quite different than the traditional HPC usage models, where you can just simply think of how much time your computation may need and to decide how big the data cluster you may want to. The Hadoop clusters, essentially, you need to consider in both your computation needs as well as the data storage and the data processing needs. So in this case, the data processing needs may be more important, or you should put more priority over your computation requirements. In this page, what you can see on the top, we are trying to give people some guidelines or suggestion on how big or how many nodes you want to request for your Hadoop clusters. That decisions should be mostly based on how much raw data, input data you have, and how many copies you may expect that data to be, and how much intermediate data set or output data it will be generating. Once you make that decisions, and you can choose how many number of nodes you are going to use with your Hadoop clusters and the duration of your Hadoop cluster, like that's your expectation of how long you're going to use it for the analysis, and a start time when you want the reservation to start. You don't have to start them right now at this moment. You can start say, oh, I'm now going to be ready by next week, so let me start my Hadoop cluster next Monday or next Tuesday. You can pre-schedule that. So once you made the reservation from the portal page, you can actually check your Hadoop reservation status through the Wrangler portal. And if you're logged into the Wrangler, you can run this scontrol command to show the current reservation in the systems. Here, I want to point out things is if you see the command there, you see there's a fields on number of nodes, starting time, durations. You also see the list of users. So that's another difference between the a slight difference between the typical reservation system or the old usage model we had with our HPC system is when you create a Hadoop reservation, when you're starting a Hadoop cluster, that cluster is meant for that allocations and meant for that project. So all the users in that allocation or in that project will automatically be included in the reservation and when will be granted access to that Hadoop clusters. Once the reservation is created and the Hadoop cluster start running, and also only the user that included in that reservation can have access to that Hadoop clusters as well. The Hadoop clusters, so in the previous page, when you make the reservation, we only ask you like 3 input parameters, and there's tons, like literally hundreds of input parameters you could give to specify how the Hadoop cluster should be started. We start the Hadoop cluster always with a set of default settings. We think it works better and works in the most times. And also in the Hadoop world, and in most cases, like maybe 90% of those parameters, you can actually override them when you actually run any applications, or you can do that per application basis or even per file basis for some of those parameters. You can, if there's really some specific way you want the Hadoop cluster being started, you are always welcome to send us emails, and we can work that out, and we can start that Hadoop cluster for you with the settings you specified as well. Once your reservation gets started and is in active state, is meaning your Hadoop cluster has been up running. You can access the Hadoop cluster through the Slurm jobs. So there are like 3 types of the ways you can access and to those nodes. So one is starting with the VNC sessions. The VNC job is you just requesting one node out of your Hadoop reservations. You're starting a VNC server on that node, then you can connect into that node through your VNC sessions. The second one is IDIV job, and Naya has been showing some examples. It's a similar case, but it's similar to the VNC. You're requesting one node, but instead of starting a VNC server sessions, you're just going to get a command line interface. It's much easier. It's more. It's a for you to really get access to it. It's just lacking of that graphical user interface there. If you don't really need any user interactivities, or you don't really need to see any of the output, your code is all sorted out. You can also just embed that command or that Hadoop jobs into a batch Slurm job, and just submitting that job to the Slurm. Then the Slurm will pass your Hadoop job into the Yarn, which is a resource manager for the Hadoop clusters, and to run it. So throughout my rest of several slides, I will run through the example of each one of those and to give you ideas how each job looks like. So the first example is through the Hadoop clusters with the VNC sessions. We have some sample scripts in these shared folders on the Wrangler login node. So you can you can copy that file to your own directory. You can edit it and to suit to your allocation, your project parameters. Once you're editing that, and you want to if you want to run, you can run this particular Slurm job with any node and with or without Hadoop clusters. And in this case, we want to run it from Hadoop cluster we just created. So we're submitting this job by specifying we want this job to be run in one of the nodes in these particular reservations. So once you're submitting these jobs, and eventually when it's getting runnings, it will automatically generating an output file called vnc.out. Once you see that files and you just see the last line, that's like 3 lines, it contains instructions how you're connecting to the VNC sessions running in the backend. This comprises 2 steps you need to do. One is to do the secure shell tunneling and to mapping the port in the Wrangler login node into your local node. Then you can do in the VNC session to that local node. Yes?
Is this reservation for the participants, or is it just specific to for the jobs that you were running, or do you want to make the reservation available to participants in the training?
Right now I'm showing the screenshots, and I also have the reservation running currently. I'm not sure what your.
Yeah, we're not set up to make reservation available to participants.
Okay.
So if you have login, you can see the reservation information, but if your username is not in the list of the reservation, you cannot access to other reservations. In the future, we may put up the more tutorial sessions or workshops on specifically how you can use them. That may be including how to programming with MapReduce and use them. In that case, we certainly will have hands-on session for people to use that. So once your VNC session started on the Hadoop nodes, one thing you can connecting them with a VNC client of your choice. When you're connecting to them, one of the nice things about doing VNC session with your Hadoop cluster is you can have access to the Hadoop cluster's web UI. The web UI can tell you a lot of more informations and in a more very nicely formatted fashions. So there's a three kind of the main function in the web UI. One is showing your node, the cluster node information. So that's what this screenshot showing you. It shows like the overall of your node configurations. So in this case, I'm not sure if you can see that clearly from a screen, but it shows you the total capacity of like how many terabytes that your current Hadoop cluster has, and how many has been used, and how many being remaining. It also will show like whether you have any date nodes. So in my case, the reservation was created using 15 nodes, and one of those nodes is being used as a name node, and then the 14 node, other node will be used as a date node. So from here, you can see the all 14 nodes are live and running, and you can use them. There's the page is there. There's more information in the rest of the page. I didn't take any more screenshots of this. And from there, you can also go to individual data node and to see the status of that particular data node as well. The other main feature of the web UI is from the web UI, you can see all the application that are currently running or has been scheduled or submitted to the young cluster, young resource managers, or has been run in the past. So it keeps entire the history of the jobs has been running on your Hadoop clusters. In this particular screenshot, you can see some of them is already done successfully, and there's one application is actually still running when I take that particular screenshots. From there, you can actually clicking on any of those job names. Once you click on those job names, it takes you to the detail page on what's the job, when this job was run, and how many mappers it has been used, and how long it has been using. And there's a little log links where if you click that log links, it can give you more information on it give you access to the logs that it has been kept on each one, on all the nodes that used to run that particular jobs as well. So the VNC sessions in this examples is give you very good access to the information and the status of your Hadoop clusters and of your job, and that would be especially valuable if you need to debugging certain error and to check the status of your cluster or jobs there. So that's a very basic things you can do with your Hadoop clusters. And once you're inside the VNC sessions, you can easily open up another terminal windows, or you can start to running another applications and to interact with your Hadoop clusters and submitting job and working on them. As I said earlier, so Hadoop initially to be just a one Java library, a simple jar file, and now it's evolved into such a big sort of like platforms. So down to the core is a Hadoop distributed file system. So that is what we are, when you asking Hadoop cluster reservations, and that is what we are going to setting up for you automatically using the Flash nodes. Then the Yarn is a Hadoop's resource managers, and it's oversee all the resources in your Hadoop clusters. And on top of that, there's many of different applications you may run, depends on what your projects needs. Some of them is not really relevant for us, and some of them is something we currently support and or we will be supporting in the futures. So we currently have, say, for example, we currently have the Pig-Latin scripting tools available on the Wranglers. So if you have Hadoop clusters, you can access to Hadoop clusters, and you can easily start the Pig-Latin script and to interact or connecting assets with the Hadoop clusters. We also has a Mahout installed on the Wranglers as well. So this is a very comprehensive machine learning libraries for the Hadoop. So everything is is implemented as a distributed algorithms. It contains a very comprehensive list of the algorithms you may need it for a general data mining or machine learning analysis needs. You can use Mahout as a individual libraries and run them, or you can have, it also has a command line interface where you can just run individual analysis directly with the file stored in the HDFS. Spark is an application that built around the Hadoops, or it can run independently, or it can run in combination with the Hadoops. So right now, we recommend people to use it as with Hadoop cluster together. So if you just simply want to run Spark, you can go ahead to starting Hadoop reservation. If you do not use that, you can just use it as Spark. If you really need to use setting up Spark as a standalone applications, we can do that. And if you have really that need, you can ask us. But we can have that one scheduled for you. But the difference between the Spark standalone version with the Spark with the Hadoop version is running Spark over the Hadoop with Spark will using Yarn as the resource managers, and it will using the resources better, and you can have multiple users to using the same Spark clusters at the same time, as long as there's enough resource available in theirs. So the Spark is also originated from these MapReduce ideas, and there's a lot of difference between Spark and the Hadoops. I'm going to spare all those details, those technical details, just in a very, very simple ways. The difference between Spark and Hadoop is one is more disk use, one is more rely on the disk, and the other one is more rely on the memories. So if you think about the two typical workflow, one is sort of like iterative workflow. You have input data, you go to iteration 1, iteration 2. So in the Hadoop world, this is going to be your HDFS. Then the iteration 1 will put the result back into HDFS. Then your iteration 2 will read those from HDFS again and using them. If you are not just one-time processing, then everything from the HDFS will be, the name node will distribute your query that will directly accessing the local nodes or the local file on each in your HDFI to do that processing. So with the Spark, it's basically replace those intermediate disk storage with just store them in the distributed memory systems there. So the second example I'm going to show is to really supporting interactive access with Spark using the IDAP sessions. So you have seen a couple of examples with how you're starting with IDAP sessions. You can requesting IDAP session with any nodes again, but if you want to use it with your Hadoop cluster, you need to specify the reservation you want to use. So once you specify that and your IDAP session has been started running, you can say if you need to use in Spark shell to do some interactive analysis, you can just using the command line command and to invoke that Spark shell applications. So here is just a screenshot on, say, once I'm having one of the nodes from the Hadoop clusters, I can just do Spark shell and specify I'm going to using the Yarn clusters in the backend and to do as my resource managers. Then I can starting all the Spark sessions, and then once you see the once you see the Scala signs, that's your Spark shell session has been up running. So with IDAP session, the Spark shell is just one application you can run. And if you have a code that has been developed with the Sparks as a Spark job, you can just directly submit that Spark job, and that Spark job will be running in the will be backed up and running with the Yarn in the Hadoop cluster as well. So in this particular examples, on the top line is the command I'm submitting. Again, I'm going to speak using the Yarn cluster in the backend. So here's a kind of quick job output where you see it's the Yarn, the Spark will send the job as a Hadoop job to the Yarn. Then Yarn will assign resources to run that jobs and pass the status. And then when it's finished, it will tell you it succeed. Then if your application writing another new file in the HDFS, you can access that file, or if it's from standard out, you can get in those standard out output from the Hadoop clusters as well. So that was second examples, and you can run with doing interactive analysis with IDAP sessions. The third examples I want to run quickly is running a user application with Hadoop at the Slurm batch jobs. So through our testings, and one of the applications we're currently testing is a particular tool called the Crossbow, which is a scalable tool for finding SNPs from the short read sequences. It's one of the things people doing sequencing analysis commonly do and quite a lot. On the left, it's kind of overall workflow on how Crossbow works. It's store your data in the HDFS systems, and then it's wrapping around a bow tie jobs as a Hadoop streaming jobs, and to go through the mapping and the reduce phase, and to identify the SNPs. We have the Crossbow. It's one of the things we're used to testing the Hadoop clusters, but it's also available for user to use in the on the Wrangler. So if your research does need that particularly applications, you can talk to us, and we can setting up the jobs for you as well. But here, just a quick screenshot of the job scripts I'm using. So where you can see the couple of things I want to notate from these job scripts is unlike a traditional HPC job scripts. Here, I only need to requesting one node because the purpose of this Slurm job is just to requesting one node where you can submitting your Hadoop application to the Yarn resource managers. So you don't need to requesting a lot of more nodes than one. So once your job is running, all it does, so in my case, I do some environment variable settings, and I clean up some old directories I used to testing with the Hadoops, and then I basically run this command, which this command comes with a Crossbow, but it's just a wrapper for the Hadoop streaming jobs where the job being submitting to the Yarn. So all this may take like less than 5 minutes for Yarn to finish to process. So once it's finished, your Crossbow job will be still running on a Hadoop cluster in the backend. Even your Slurm job can quit and terminate. So your Slurm job can have a very short duration when you do the request as well. It doesn't need to consider how long your Hadoop job will actually took. Just quickly, some of the performance from our preliminary testing is the big graph you see here is, well, it's kind of messed up with the format here. I don't know why. But for the first graph, what you're showing is sort of the average I/O throughput and the I/O rate. So the test was done with reading 1 GB file, and then we have reading a number of them concurrently. So starting with the sort of basically, if you're just reading one file, you pretty much can get 1 GB per second of reading performance. So that's for mappers. If you're concurrently reading, say, the 100 files, you're getting somewhere like about 800, 900. If you're reading like 1,000 files, that average performance per mapper maybe drop to the 400. But that's, again, it's average performance per mapper. So if you reading 15,000 files with 15,000 mappers, the overall the throughput is still very high. There's something wrong with the formatting here, but for the Crossbow, we have a testing with the rice genomes, which we have like the 46 million of the short read sequence, and we're comparing that with the 2 billion of the base pair from the rice genomes, and it only takes like less than 6 minutes for the whole computation to be done. We also run a terabyte sort, and which terabyte sort is one of the standard testing people run with the big data analysis. For the 1 terabyte, it can be finished in under 8 minutes on the Wranglers. So that's about how we're supporting the Hadoop and Spark type of analysis. And for the general data analysis tool support, so a lot of those are the same as what we currently support on StampP as well. So for example, the R is a popular high productive analysis package a lot of domain size people use, and there's a lot of the domain specific package or topic specific package available through the current website. So we have basic R module installed on the Wranglers. It is same R module we currently installed on the StampP and the Maverick as well. If you just want to use R as is, you can just do module load R stats, and it will load R environment, and then you can start using R. On StampP and the Maverick, we're supporting people running the R Studio session over the web. We will do the same for the Wranglers, and we have a similar R Studio job script setting up. You can do as batch and to submitting that R Studio Slurm scripts. Once it's starting and you look at the last two output, you can see a link is generated for you to connecting to your RStudio session on the web. So here's just a screenshots on the RStudio session on Wrangler through the web interface. The R also supporting parallelisms, and it has built-in parallel package, and there are also many other parallel packages supporting R to using through the MPI or OpenMP type of parallelisms. We will continue supporting those on the Wranglers, and we have a very comprehensive and detailed training on that about R. One of the things differently on Wrangler is we're going to supporting using R with Hadoop streamings. We currently, so the Hadoop streaming API is coming with your Hadoop cluster, so you can use Hadoop streaming API to stream any the program you're writing in any other language. So in this case, you can write in your R scripts as mappers and reducers and submit to the Hadoop clusters as Hadoop streaming jobs. So other than Hadoop streaming jobs, and there are also package available that specifically made for R to use to utilize in the Hadoop and Spark type of analysis. So we currently supporting the repays on the Wranglers and Spark R. So repays one we find is it has a better performance for R to utilize in Hadoop clusters, and the Spark R is a package to enable R to directly use the Spark clusters to do the processings. So other than R, we have more analysis tools on Wranglers, like Python and VCAS and many others, and we may gradually adding them into theirs. And if you have a particular software tools you want to use and you need, feel free to let us know. We can add it, we can add them, we can install them on Wrangler as well. One of the things we want to highlighting is for those tools, you can also make them to connecting to things like R and Hadoop as well. So Python has connector, VCAS now has connector with R and Hadoop and Spark as well. So we really want to make, if you have very complicated workflow that use different type of technology and programming language, that can still works on Wrangler as well. So here just some quick screenshot about using IPython notebook. It's the same thing we do on Maverick, and here's a VNC session where you can start in the VCAS and to do some small data analysis task in the interactive way. And VCAS also gave you a lot of the support on the visualizations on your input data and your class and analysis result as well. So the last is we want to say, so we're not just a software support, and we have staff support as well to helping people to getting started to do the analysis with Wranglers, and we have people expertise in Hadoop, Spark, and in R analysis as well. So if you are interested to use them, but you do not currently know how Hadoop work and R works, don't worry. We will have a more tutorial and more detailed technical kind of workshop to teach people how to do that. And you can also request for the extended collaborative support through the ECSS. Yeah, so I think that's my last slide.
All right, well, that was sort of a very, about as fast as we can go through all of that information, and probably a lot of this is the sort of things that we're just hoping to get out to people so that they can understand what Wrangler's capable of doing and start asking questions and figuring out where we need to go next. So I wanted to sort of open it up to the folks here in the room and also out there attending the webinar to sort of discuss either if you have particular questions or if there's anything you want to talk about with specific use cases or ideas that you have for Wrangler. But then put a plug in here while we're waiting for the webinar to catch up. We'd also encourage you, we already have a scheduled, I believe for May 8th, is a databases on Wrangler sort of deeper dive. Another webinar, an in-person thing where we'll talk a lot about what Chris got into at a very high level here, but sort of, you know, what you really can do with databases and what you can take advantage of in the Wrangler system. Similarly, Weijia was talking about many of these data analytics portions, and we're interested to find out, you know, what people think is they would like to sort of dive into first. So whether these are sort of the R and Python analytics or the Hadoop Spark or the crossovers between those. Or if people are interested in hearing more about sort of the data management and how you can use the systems that we have on Wrangler to better manage the information that you have and share and collaborate with others, as well as come up with plans to make sure that, you know, when you come back to your data in 6 months, you can figure out what you did. You know, some really good best practices and things about how you can manage data. And any other suggestions, we'd like to sort of, you know, reach out to folks. So either in chat or here in the room directly, or by sending email to us, and you can get in touch with any of us by way of that data@tac.utexas.edu email address. We'd like to hear about what's of interest to folks. So I will turn it over to for questions, and hope that we have a few maybe online as well to discuss. Sure, we got an online question, and I will repeat it.
To reserve Hadoop clusters, do you use VM or Yarn? Can do that. To reserve.
So the question is, how do you reserve? Essentially, how do you reserve the clusters for doing Hadoop work? Those are reserved by way of that data portal that we were showing earlier in the same area where you're allocating databases or other clusters. And what that does is actually then go and get those nodes and then configures the Hadoop system on that cluster. So there will then be all of the components that Weijia was talking about, the Yarn scheduler and all those things running for you within that cluster. But the reservation itself is handled by the web portal. Once the cluster is running, then you can start interacting with it in the ways that Weijia was talking about.
And the Hadoop cluster we started for each project is a sort of private instance for each project. So you are not sharing that with another larger sort of Hadoop cluster in the backend. So when you make the reservation, the Hadoop cluster is starting from scratch. And similarly, when your reservation is ended, the Hadoop cluster will be ended as well. So you need to make sure move out your data and when you type before your reservation ends as well.
Sure, and just to repeat that in case this microphone isn't omnidirectional enough, I would want to say that when you start a reservation with Hadoop, Weijia was reminding everyone that starts up a brand new Hadoop cluster with no data installed within the file system. It is a Hadoop cluster that's for this project alone, and nobody else is sharing it. So nobody can get in the way of your working on the system, which is sort of the benefit. You're not queued up with other people's jobs other than folks in your own research group. But the key points are when you bring it up, you will have to do the data import into the HDFS file system to get things going. Do your compute for the duration of the reservation, which we hope is a rather long reservation so that you don't have to be pushing data into the system with any regularity. But then before the reservation is up, you do have to export the data from that Hadoop environment back into the sort of persistent file system. For either future computations or if these are the final results for further analysis, for your final analysis.
So there's update on question. How long does it take to create the reserved clusters? I'm assuming he's asking the Hadoop cluster. So right now, the actual time to the cluster from start is about 10 minutes.
So the question was a question about how long does it take for a Hadoop cluster to come up from scratch like that. You can actually request a reservation starting as soon as possible from the web page for both Hadoop and for regular reservations. But the point is to get everything going, to get all of the HDFS file systems and all of the daemons running is taking on order of 10 minutes to get the whole system up and going and ready for you. And again, that's sort of a reason why we anticipate people having longer reservations than just a few hours, because there is overhead involved in all of the configuration and data motion. Well, we've hit 3 o'clock here in the Central Time Zone, so we're a little bit over our time, and I do want to thank everybody for coming. If there are more specific questions or discussions that people wish to get into, or to begin to talk about, how you can use Wrangler, or maybe to talk about things that we may have missed covering in all of this, I will point out again that data@tac.utexas.edu is a way to get in touch with us by email, or you can go to the TAC portal, which is at portal.tacc.utexas.edu, and it's possible from there for you to go ahead and file tickets into our problem reporting system, and we're willing to communicate by way of either channel, whichever you feel more comfortable with. We look forward to this deeper dive into databases coming up the beginning of May, and hope to hear from folks in the coming week to help us prioritize what we should do next as far as what services we should get into, and start to demonstrate probably more, the actual environment of Wrangler, and as we are starting to roll all this out and bringing people on. So. Okay, and there's a survey that's being sent out, that will be sent out after this, and please respond to that so that we get better feedback about how this went, how we can improve this, and what we can do to improve especially for those of you out there in the webland, the remote capabilities, because it's one thing to speak to a bunch of people in a room, but trying to have that interactive and productive feel with people out remotely is something that we're very interested in trying to make better. And so please fill out surveys and let us know how we did. So with that, I'll thank you very much, and I hope everybody has a good weekend.